velocity time graphs are weird looking graphs when you first see them, so you have to kind of get used to what they mean. They're giving you different information from position time graphs. So in a position time graph, if you saw this line here, we'll call this A, you would say, oh, well, it's not moving. Because a horizontal line in a position time graph means that something isn't moving, but that's not what it means in a velocity time graph. This vertical axis is velocity. That means that this is zero whatever, we'll say 0 meters per second. And the way to show that something's not moving is to graph it in a velocity time graph on that horizontal axis at 0. This is saying, this red line that I just drew in here is saying that this thing's not moving. But all these other things are moving. So let's say, and again, we'll say this is in meters per second. Let's say this is 10. Let's say this is negative 10. This thing is moving at a constant velocity, whatever this object is A. It's moving at a constant velocity of 10 meters per second. Let's call this B. This is moving at a constant velocity of negative 10 meters per second. So what would that look like if, let's say this is A. Let's say this is the positive direction. This would be moving at 10 meters per second. I can draw a velocity vector there. And let's say this is B, and this is moving at negative 10 meters per second. They're just going at the same speed in opposite directions. So the first thing about velocity time graphs is that I represent positive velocities by graphing their velocity above the horizontal axis, and negatives are below the horizontal axis. Another thing about them that for some reason people have a hard time with sometimes is that the farther something is from 0, the faster it's going. So let's say this is negative 2, and let's say this is positive 4 right here. Because it's farther from 0, it is going faster. Now, I think what messes people up, especially with the negatives, is you think, well, negative 2 is a bigger number than negative 10. But remember that negative sign is only indicating direction. I could call it left or right or north or south. So that's only indicating direction. So that's another thing you need to know about these velocity time graphs. Down here, where I drew the velocity of A and B, this plus 10 and this minus 10, I put the points here and I put them heading toward each other arbitrarily. This isn't giving me any position information at all. So if I gave this to you on a test and I said, what's the distance between A and B? You would not know. If that's all I gave you was this graph, you would have no way of knowing. This gives you no position information at all. We're going to see later that it gives us displacement information, but it doesn't tell us where something is. You would have to get that information some other way. So those are the basics for a velocity time graph. So let's take this example. You're taking a walk and you see an old friend heading toward you. Get my pen going here. Jogging. So you're walking, your friend is jogging toward you, which hopefully you can understand would mean your friend is going in the opposite direction compared to you. So let's say this is you and you are walking. And here's your velocity vector. And here is your friend. We'll try to make your friend running. And we'll make a longer vector to show that this person's going faster. Well, I have to decide, and he's coming toward you or she's coming toward you. I have to decide what's positive and negative, so I'll stick with the standard number line. I'll say that your velocity is positive, your friend's velocity is negative, and your friend is going faster. So how would that graph look? It would look like this. So you would be going at some positive velocity, and this is just a sketch. So, right, I wouldn't have any necessarily any numbers on this thing because I don't have any numbers in the problem. And your friend would be going in the opposite direction and faster. I would indicate faster by putting your friend's line farther away from 0. The farther you are from 0 in a velocity time graph, the faster you're going. Remember, whether you're above or below the horizontal axis only tells you about direction. So let's see if you can sketch this graph. Now here I've just arbitrarily, you can see at the top, made left positive. I could have made left negative, but I didn't. So I chose left as the direction for positive, and hopefully you can see both of these objects are going in a positive direction. And hopefully you can see that A is going a lot faster. So A is going to be the green line, and B is going to be the red line. So we have two objects traveling with a positive velocity, the green one going much faster than the red one. How would I graph that? And we'll assume they're going, in this case, at constant velocities. I would show it like that. So they're both going in a positive direction. and the green one's going much faster than the red one, and I indicate that speed by putting the green line higher than the red line, farther from 0. How about this one? Now I have them going in a negative direction. Why is it negative? Because I called it negative. I could have called it positive, but I didn't. So now we have 2 of these things going in a negative direction. We have the red one going faster than the green one. So I would have to indicate that I have both of these objects are negative. I would indicate that by graphing both of them below the horizontal axis. And the green one would be closer to 0 to indicate that it is going slower. So that's how I would sketch that. The fact that these are just horizontal lines indicates they're traveling at a constant velocity. Now you have this. See if you can figure out what's going on here. See if you can graph it. Maybe hit pause, and I'll put the answer up in 2 seconds. There it is. So these look like they're going at the same velocity, or I'm sorry, at the same speed, in opposite directions. So you have the red one going in a negative direction. Why is it negative? Because at the top I said to the right was negative. You have the green one going in a positive direction, and they're going at the same speed. So I would indicate that they're at the same speed by putting them at the same distance from 0 meters per second, or from the horizontal axis. See if you can sketch this one, and I'll put the answer up in 2 seconds. There it is. So you have, now I've switched. Now I made positive to the right and negative to the left just to mess with you. And we have the green one going really slowly in a positive direction. We have the red one going really fast in a negative direction. I would indicate really slow by having it close to 0, and I would indicate positive direction by having it above the horizontal axis. I would indicate really fast by having the line for that red one far from 0. I would indicate that it was negative by putting it below the horizontal axis. Look at this, isn't this spectacular? So you have the green one going really fast. I'm calling upward positive. I could have called it negative, but I didn't. So you have the green one going really fast, positive, and you have the red one going really slowly, positive. See if you can draw that. And hopefully you got that. So slow and positive means they're both above the horizontal axis. Slow means close to 0. Fast means far from 0. I don't know how many more of these there are. I think this is the last one. So see if you can sketch that. I'll put the answer up in 2 seconds. There it is. Hopefully you got that. So this is the beginning of being able to understand what these velocity time graphs represent. And now we'll get into doing a little bit of math with them.